The next week, I hope we will arrange the splitting of the group, and then we'll do the lab. As I told you sometime before, so the group needs to be divided because the lab cannot accommodate so many people. So we'll split the group in two parts. The coordinator will contact with you just for the
Excuse me,
time, which
doctor.
is,
Would you please speak up? Your voice is low.
you cannot hear me?
Yeah, I hear you, but your voice is very loud.
Oh, wait a second, please. Okay, so what about now?
Yeah, yeah, that's okay. Thank you.
Oh, okay, all right. So I was talking about the lab to split the group and have two different sections, and then to do two labs for the group. So one will be at regular time as you have the class and lectures. Just since we are talking, since we have this practical at 10, I want to shift a little bit um, the session towards like morning. So we might start at 9 because you're supposed to have at 9 the class anyway, right? Because there is a lecture uploaded. So, but we'll do it not today. It was not, but because we are talking today, I'll talk about the lecture which uploaded last week. But about the lab, we will start at 9, and but the second session I don't know, so the coordinator will contact with you, so the time will be set the convenient for you, and yeah, also should be available, right? So we'll find it out what is the good time. This is about the lab, and you know that this is 5 point uh, assignment. I'll send out the handouts for the lab, so you will need to read it and be prepared for the lab to know what to do. I'll explain in the lab as well, but there will be many things to calculate, and you need to understand what you need to calculate because from last experience, yeah. So you need to do. You have to be prepared. So just to be short. Um, so I'll just, there are some couple of people left about the exam to be graded, and I'll just finish after the class, and you will know the grades. Yeah, do you have any questions about the lab or anything?
Yeah, doctor. You said for next week we have first session of lab. Yeah.
Right. Hopefully. I
For,
asked the
for
coordinator to set it for the next week. So if we find the time, yes, next week.
okay. You mean that's time can be variable because you are not in Georgia now because of visa problems. As I sent in email
Yeah,
to you
I
last month.
remember. I remember. So I asked about this. If you come sometime later, so maybe you can make up the lab, say like that. So for those people who are not here, maybe there will be one additional session arranged. I'm asking about this. If it is allowed, we'll do like that way. If not, we'll think about different options.
Okay, thank you so much. And another thing, you said you want to prepare some subjects for our lab part, and we have to prepare it.
No. I'll just send out the handouts because during
Uh-huh.
the lab you have to do experiment and you need to write the report about this experiment. And for the report there is a particular form, so you need to write it in that form.
You mean
And
after, excuse me, you mean after participating in lab part, we have to prepare a report?
right. So what is happening that during the lab, when you are doing experiment, you are writing down some data, right? So because you are
Uh-huh.
measuring something, so you need to measure, you need to write it down. So you will be writing down these data in that form. So I'll send out the form. You just need to be familiar with that. I will bring print it out with me to the lab, but ahead, you need to be prepared for that. What you need to think, what you need to write in there. So then, once you have datas, then you need to calculate some parameters based on those datas. Okay. So
Okay.
once you finish the experiment, you sit there and write up everything in the report in the form, and then you hand it in to me. Okay.
Okay, thank you. Another thing, doctor, I have one difficulties in our midterm exam.
Yeah.
There was one question I cannot calculate that. Would it be possible I send a question and you help us to how we can calculate this question?
Yes, please send to me the question, and then I'll look at that,
Just,
and then we'll discuss
just
about that.
now I can send it in chat part.
Okay.
So can you see it, doctor?
1 second. Yeah. So okay.
This
So
question was completely unfamiliar to me and I cannot calculate it.
yeah. So we discussed about this type of questions, and we had some examples of that. So okay. So let's just do like this one.
Thank you.
Okay. So hello. What's going on here? Okay. So can you see the screen now?
Yes, doctor, yes.
Okay, so the question was, I'm just taking any type of question, not exactly that one, but I'll just write the type of question. Say you have delta H, as I remember. Why I cannot write any? Okay, so you had delta H, as I remember, say it's, I don't know, 230 kilojoule, right? Kilojoule per mole. And the entropy delta S, you had change of entropy, say you have 150 joule per Kelvin per mole, right? And then you need to find the temperature when the process is spontaneous, right? So the approach is very simple. So you have delta G, which is delta H minus T delta S, right? So first of all, what you need to do is that you need to make this one conversion. So you need to convert it. So you have kilojoule here, you have
Yes,
joule
doctor.
here.
This phase of question is really easy for me. But
Yeah,
we have temperature in Kelvin in the question.
right. Yeah, so what's wrong with Kelvin? I mean, what's wrong with Kelvin? It doesn't matter. Your temperature have in Celsius or in Kelvin. It doesn't matter. So, I mean, you can convert it to Celsius if you want, but you can leave it in Kelvin as well. It doesn't matter at all.
Uh,
You do not have to convert it to Celsius, because see, you have Kelvin here, you have Kelvin here. It's Kelvin per mole, and temperature is also Kelvin, right? So you can match this Kelvin and this Kelvin and leave everything in Kelvin, for example. It's not a problem at all. Just only thing you need to do is how to approach this problem. So you can plug in
delta H per delta S.
yeah, so you just need to calculate delta G when it's not delta G, but you need to calculate this one when delta G is 0, first of all. Okay?
Yes.
Then whatever you can get T, then delta G will be less than 0 when this T is higher than you calculated. So you can just say that at any point when T is higher than you calculated, the process is going to be spontaneous.
Oh, yes.
That's it.
This was really easy question, but
It's a very easy
unfortunately,
question.
I missed the point.
Yeah, that's the easy question.
Thank you,
We
doctor.
practice it about this one.
Thank you, doctor. Yeah.
Okay, so any other questions?
No, thank you.
All right. So let's just talk about, we'll talk about pH today. What is pH? And we'll talk also about buffer solutions. This is a very important topic. I mean, for everybody who works in chemistry or who works in medicine, it's a very important point. Let's just talk in general about pH. What is pH? And you can see this slide over here. And just 1 second. You can see that these are cells. So this is a cell, for example. Okay, and these are nanoparticles, but don't consider this one. We don't need these nanoparticles. This is called nanoparticles. This is just a cell. Okay, and you can see on the left-hand side there is a cell. It says pH 7.4, and here the pH is 6.5, right? So what is difference between these two? So these are the same cells, as you can see, just one is loaded with gold nanoparticles, the other one is not loaded, but we don't care about gold nanoparticles. We just care about the pH here. So you can see that the pH are different. Can you suggest any reason why the pH is written here as different? What could be the reason that pH at one side is like 7.4 and other side is 6.5? What could be the difference between these cells?
Doctor, excuse me. One reason can be, we can say, in normal pH range, the small particles are free in the cell. But when our pH is getting lower and it's getting on acid part, the micromolecules come into the cells.
Okay, so you are talking about these particles, or?
Yeah.
No, no, disregard these particles. They just shown here, but there's no reason to consider these particles. But okay, so I understand that we have different pictures. One of them is loaded with particles, the other one is not. But indeed, the reason is different. Actually, this is the normal pH, which we have in the blood or in body fluids. Mostly, not in every part of the organism, but mostly this is the normal pH in blood. Okay, but this is a low pH, and as you said, you're right, it's acidic. It's a little bit acidic environment. Okay,
yeah.
But what can be the reason that we have the same kind of the same part of the organism, but the pH is different? In one case, is that we have normal cells. This one is normal cells, and you can see the environment is a little greenish, right? But here it's a little different color. What is happening that these cells are not really normal, even if it looks normal, but there is a development of tumor cells in in the side which is pH 6.5, and usually tumor cells show low pH because it's acidic environment around the tumor cells, and this is why the pH is different for normal cells and for tumor cells. Okay, or cancer cells. So one case is normal cells and the other one is cancer cells. So let's just discuss about acids and bases, because the pH is related to how acidic is environment and how basic is environment, right? As you studied it, about pH. But let's just talk about acid and base aqueous solutions. So what is the acid? So acid is the compound which can provide hydrogen proton or hydrogen ion. You can see the hydrogen ion. It's a plus charged ion. And when dissolved in water, for example, if you dissolve HCl in water, so it's gonna be broken up in H plus and Cl minus, right? So this H plus, once it's produced, the environment becomes acidic. The other thing is for base. So when substance produces a hydroxyl ion, OH minus, for example, NaOH, it produces, once you dissolve it in water, it's going to produce Na plus OH minus, right? So this OH minus makes environment basic, okay? And if you react HCl with NaOH, the neutralization reaction may happen. For example, if you react HCl plus NaOH, you will have very unharmful, I would say, salt, which is table salt, and water. Okay. So this is why it's neutralization. So you neutralize the properties and the characteristics of NaOH, which is strong base, and HCl, which is strong acid. So you basically completely strip off these chemicals of these properties. Okay, this is why you neutralize these two. Also, if you dissolve HCl in water, right? So you also can produce hydronium ion. This is basically the same as hydrogen ion, it's just H plus H2O. That's the same thing. So if you have something like this, it means that the environment is acidic. Okay. This is hydronium ion. You can see the potential map on that, and you can see one part is red, the other one part is blue. So it shows the charge separation on hydronium ion, and this red one is more negative, and blue one is more positive. Okay. So yeah, so you see this, sometimes it's H3O plus and H plus, they are interchangeably used. So but both of them represents basically acidic environment. Okay. As I said, how you can produce OH, as I already showed you. So you can just dissolve NaOH in water, and you can produce OH minus. But there is also another way to produce this. This is from NaOH. You see, it has OH, so this is just produced from NaOH, sodium hydroxide. But there is another way to produce OH. For example, if you dissolve ammonia in water, you will produce ammonium ion. You can see here NH4 plus and plus OH minus. So this OH minus comes from water, but this NaOH minus comes from NaOH, right? Okay, so now let's just, this is just in general, like what is acid, what is base, but we need to also discuss about Bronsted acid. Okay, so Bronsted acid and Bronsted base. So what is the difference between these two? Bronsted acid can donate the proton. So if anything has capability to give away the proton, that's going to be Bronsted acid. And Bronsted base is the one which can accept the proton. Okay, so that one can be Bronsted base. So not to be confused with acid and base. It's a little different concept. Okay, again, please remember, it's about donating proton and accepting proton. If it is Bronsted acid, it donates proton. Excuse me. If it is Bronsted base, it accepts proton. For example, look at this one here. So in this case, H2SO4 is Bronsted acid because it can generate 2 protons, right? If you dissolve it in water, it's going to generate 2 protons, and also this SO4 2 minus, right? In this case, SO4 2 minus is going to be Bronsted base because it can accept these 2 protons and become H2SO4. But H2SO4 cannot accept any protons more. So that's it. So it can accept only 2, and that's it. So because of that, this cannot be Bronsted base. It's only Bronsted acid. But for example, HSO4 1 minus. So this one can be also Bronsted acid and Bronsted base, depending how we'll work with this, right? So if we add H plus, it's going to be H2SO4. So in this case, HSO4 minus is Bronsted base, right? But for example, if we write something like this, in this case, this HSO4 minus is going to be Bronsted acid, okay? Because it gives away the proton, so it can donate the proton. So you need to pay attention if the compound is capable to give a proton or accept the proton. That's going to be determining if it is Bronsted acid or Bronsted base, okay? Now let's just discuss about conjugate acid-base pair. All right, so conjugate acid-base pair. What does it mean? For example, we have, if we take this again, this H2SO4, we can consider that H2SO4 and HSO4 minus. It's an acid-base conjugate pair. So what does it mean is that? So in this case, H2SO4 is acid conjugate and HSO4 minus is base conjugate. Why? Because this one can donate proton, can give away the proton, right? If you dissociate this one, it's going to be like this: H2SO4 H plus HSO4 minus. Okay, so you can see that this H2SO4 can give away the proton, but HSO4 minus can accept the proton, making H2SO4. Okay. So because of that, these two are acid-base conjugate pair. Is that clear? Okay.
Yes, I think it's
all right. So
I
now let's just look at the equation over here. So we have acetic acid, CH3COH plus H2O. We make acetate, CH3CO minus plus H3O plus, okay? Can you now tell me which one here is conjugate acid base? Can you think about that one? Which is gonna be conjugate acid base? Can you couple?
acid one with the base one.
Yes, exactly. So acid one is going to be conjugate with base one. So it's written over here, right? So CH3COH is conjugate with CH3COO minus. Yeah, so this two is going to be acid-base conjugate. And the second pair is going to be base 2, acid 2, right?
Right.
Yeah, so it's going to be H2O and H3O plus. So it's going to be base, this is going to be acid, okay? Yeah, for example, it just here we have example of carboxylic acid. So this is acetic acid. You can see here this acetic acid. So not to be confused which H is lost, for example, which H can be donated. So because it has 3 over here, right? There are three more. So 1, 2, 3, and there is also one more here. So we need to know that the H which is bound to oxygen, that one is going to be donated, not those which are bound to carbon. Okay. So that the H is going to be donated. Right, so same thing we can write for ammonia. So ammonia is dissolved in water and we make ammonium ion and OH minus, right? So here we have acid base conjugate as NH3 and NH4 minus, plus, I'm sorry, right? That's our
Yes.
acid base conjugate. Which one is acid? Which one is base? This is base. This is acid. Okay. Now
Okay.
here about water is a little now different. So look. So we have H2O, and what is going to be the conjugate pair of H2O?
H2O here, it's acid.
Right, but what is the pair of this acid? What is the
OH
conjugate?
minus.
OH.
Right, so it's going to be OH minus. So now you can see that water sometimes can be acid. In this particular case, it's acid, but in this particular case, it's base over here. See? So this might be different actually for water. It can act as a base and also as acid, depending what is the product. In this particular case, it's acid, but here it's base.
Yes, that's amphoteric.
Say it again, please.
That's amphoteric. That's mean.
Not really about water. You don't say like amphoteric. It's a little different. It's about oxides. You can say about oxide, but about water, it's quite unique. It's like standing alone from all compounds. So yeah, it has this kind of feature that it can be acid, also base. Okay.
Okay.
Well, this is just some common acids and bases. I want you to have idea about like most some very common acids and bases, because we usually these are used very often. And for example, sulfuric acid, which is very important raw material um, for the chemical and pharmaceutical industries, and I mean also in industry, sulfuric acid is one of the most used acids. Hydrochloric acid or muriatic acid, as it's known historically, it's also very application of this one very wide, and in industry also, in the lab as well. Phosphoric acid is also widely used. So H2SO4, HCl, they are strong acids. H3PO4, phosphoric acid, is not that strong acid. Okay. For fertilizers, phosphate fertilizers, it's used phosphoric acid in that industry. Nitric acid is also quite a strong oxidizing agent, and also it's used in fertilizers to make ammonium fertilizers. Also in military explosives it's used, but it's also for fertilizers. Sodium hydroxide, which is called caustic soda, is also very widely used. For example, if you have seen drain cleaners, so if there is a plug in a drain, so there's a special solution, and mostly it's basic solution, which contains caustic soda, which is NaOH, and so on. Ammonia is also also used for fertilizers. This is just a list of acids and bases, and which one is strong one and which one is weak one, right? Because you can think that it is the strong acid, it means that it's absolutely weak base, right? Because it cannot be both
Right.
together. So, and opposite. Um, so if it is strong acid, it's going to be weak base. So this is weak base, very weak base, but then these guys are very strong bases, for example.
Yes, strong base with weak acid.
Right. So it's like if something is strong acid, it means that it's weak base. So the stronger the acid, the weaker its conjugate base. Yes, right. It's usually like that. If you have strong acid, its conjugate is going to be weak base.
Weak base, yes.
Let's just see how this acid-base environment is really indeed in the organism. For example, one of the examples here is stomach, okay? And the environment inside the stomach is very acidic. It's very important to have particular acidity inside the stomach because a lot of I mean, good health is really depends on the stomach, one thing, right? And it's essential. The acid in stomach is essential for digestion of proteins, absorption of micronutrients. Okay, it's very important. For example, calcium, magnesium, iron, B12, vitamin B12, which has cobalt in the heme. And it also creates a sterile environment. So because there are so many stuff coming in stomach, right? And it just this acidic environment kills down all these bacteria and some stuff. But the problem is that if it is too acidic, then this acid leaks up. If you look here, see this one. So this is stomach, right? So this is stomach, and this is esophagus. And you see, this is stomach acid over here. If it is too much, then it goes up to esophagus. Okay, esophageal sphincter. Okay, it goes up, and then there is a sensation of burning sensation. It's called heart burning sometimes, right? So of course it's not really pleasant, but also if it is very chronic, it can then cause disease, which is called gastroesophageal reflux. And if it is persistent, then it can grow up to disease. But ironic thing is that opposite way, if there is lack of acid in stomach, it's also a problem, because to get out some remains in stomach, there is a valve which is sometimes closed, sometimes open, right? To get out of these remains, and to small intestine, right? To small intestine, and this valve opens when there is enough acidity in stomach. If it is not enough, it doesn't open. Okay, if it doesn't open, then all these remains go up again to esophagus, and again it causes some burning sensation. So again, the acidity in stomach must be just normal, and which is around, I think, 2 pH or even less than that. All right, so now let's just see how can we understand if the environment is acidic or it's not acidic. What makes it strong acidic environment? So there is a particular parameter which tells us if the environment is strong acidic or not. So it is called dissociation constant, acid dissociation constant. It says over here. Okay, so what is this acid dissociation constant? So if you look to this general equation, say this is acid, some kind of acid, okay? So it reacts with water and it gives us hydronium ion and remains of acid, right? So the dissociation constant is a ratio of products over reactants. Okay, so this is product, this is reactant. As high is this number, as strong is acid. So you can
Yes,
understand that. So it means that it's very well dissociated. So as it is dissociated, as more hydrogen ion is produced, as high is acidity. So if K is high, it means that this is a strong acid. All right. Yeah, so it says over here that because water is solvent as well as participant for the reaction, its concentration is essentially constant and has no effect on equilibrium. So usually you can rewrite the equation like this way. You can see that there is no water anymore here because it's just plenty in there. So usually it doesn't affect on the concentration of on the dissociation constant, so it's constant. So this is why what is important is to have this ratio high. Okay. Well, as I said, strong acid has K value much greater than 1, and weak acids have K value much less than 1 because dissociation is not favorable. Okay, so now let's just see again about water a little bit. Let's talk about water because it's very important. We need to understand how water participates in making environment. It's very important because, as I said, water can generate both. Water can generate hydronium ion. It can generate hydroxyl ion as well. So hydronium ion is acidic. Hydroxyl ion is basic. So we can say that dissociation of water goes in this way. So we have water, it can dissociate as hydrogen proton and hydroxyl ion. It doesn't mean that water dissociates a lot, but some of molecules of water dissociates, and it gives us what is written here. Very important parameter is the ion product of water. So what does it mean then? So it's really key parameter, and its value indicates the acidity or basicity of the solution because only a very small fraction of water molecules are ionized. The concentration of water remains virtually unchanged, as I said. Therefore, equilibrium constant for the auto-ionization of water is product of hydronium ion concentration and hydroxyl ion concentration. So
yes, we can use it for calculate OH or H3O.
Exactly. So it's a very good parameter to calculate OH or H3O plus. I have less than 1 minute, but